All right, so we have made it to level 2, which now we're going to be dealing with literal equations that have more than 2 variables. Again, these equations really are no different than equations with numbers in them. For example, number 1 looks maybe something like this. 1 minus a 3 is equal to a 1 plus a 2x. To solve this equation, what we would do is we would subtract 1 from both sides first, and these 1's would cancel out, and we'd just be left with a negative 3 is equal to a 2x. Same with this equation over here, the literal equation. If I subtract m from both sides, my m's cancel out, and I'm left with a negative p plus a bx, is equal to a positive bx. So it's very similar to now the yellow equation, which to solve the yellow equation, what we would do is we would divide by 2 on both sides. And then same with the green equation. I'm just going to divide by b on both sides. It's very, very similar to a normal equation. And now I have x is equal to a negative p over b. And x is isolated, which is exactly what we were trying to solve for. But it's no different than this equation here that I gave you with all numbers and just one variable. So same with number 2. Number 2 could look something like this type of equation. A 2 times a 3 plus 5 is equal to a 4x. Well, if I'm just solving for x here, what I would do in this equation is I would just divide by 4 on both sides. And then I'd actually just simplify the 2 divided by 4. So same thing with my literal equation. If I'm just solving for x, I have a 4 times an x. What I'm going to do is I'm going to divide by 4 on both sides. And when I do that, I can do the 2 divided by the 4. And that reduces to a 1/2. So then in my numerator, I'm just left with a b plus an a. And then the denominator of 4 divided by a 2 is a 2. And that equals x. You could also write this answer as a b over a 2 plus a b over plus an a over a 2 is equal to x. Or it could also be a 1/2 b plus a 1/2 a is equal to x. It's up to you how you want to write your answer with that, but I'm just going to leave it as a b plus an a over a 2. All right, number 3. I'm not going to do a normal equation side by side, or actually I could. So maybe we have a 7 is equal to an x over a 3 times let's not do 7, that doesn't work obviously. Let's do a 6 times a 2. All right, so if I were to solve this equation for x, I'd take care of parentheses last, so I'd take care of that times 2 first and divide by 2 on both sides. So then I'd have a 3 is equal to an x over a 3 because these 2's would cancel. Same thing with number 3. I'm going to first do the divided by p on both sides. So I have a y over a p is equal to an x over a 3. My p's cancel. To solve the blue equation from here, I would multiply by 3 on both sides and get a 9 is equal to an x. So same thing with the red equation. What I'm going to do is I'm going to multiply by 3 on both sides. This is technically really a 3 over a 1. So I really just multiply the 3 by the numerator. So I have a 3y all over a p is equal to x. And that's it. So again, these are not much different than normal equations. They just have more variables. So looking at number 4, I'm not going to do the normal equations now. I'm just going to deal with the literal equations. So in number 4, technically there's imaginary parentheses around the numerator here. And in order of operations, we take care of parentheses last. So I'm first going to start off by multiplying by p on both sides. So I have a pm, or an m times a p is the same thing as a p times an m, is equal to, these p's cancel out, and then I'm left with just my numerator of x plus an n. I'm adding an n to my x, so to undo that operation, I'm going to subtract n from both sides. So I have an mp minus an n is equal to an x. So I solved for x, and that is my final answer. All right, looking at number 5, this one's a little tricky. I have a 2/3 times an x times a g. So what I'm first going to do, I'm going to show you 2 different ways to do this problem. I'm first going to divide by g on both sides. Actually, I'm going to show you 3 different ways to do this problem. So then I have a 2/3 x is equal to a b over a g. And remember I told you guys that we should never ever divide by a fraction. So since this 2/3 being multiplied by x, normally we would divide by that number on both sides. But I'm not going to divide by 2/3 because I should never divide by a fraction. So instead what I'm going to do is I'm going to multiply by the reciprocal of 2/3, which is a 3/2 on both sides. A 3/2 times a 2/3 cancels out, and I'm left with an x is equal to, and then a b times a 3, I write it as a 3b. And a g times a 2 I write as a 2g. And that's it. X is isolated. Now what you could have done is you could have gotten rid of the fraction by multiplying everything by 3. So with 3 times a 2/3 times an x times a g, you're going to be left with a 2xg. And that will equal a 3 times a b, which is a 3b. And then I have an x times a 2 times a g. I could actually just divide by a 2g all in one step on both sides. So the 2's cancel, the g's cancel, and I'm left with an x is equal to a 3b over 2g. So that was another way to get that problem, or to get the answer. You get the same exact answer here. The third way that you could do this is you could have a 2/3 times an x times a g is equal to a b. This is the more complicated way. You could have first started with multiplying by 3/2 on both sides. And I wind up with an x times a g is equal to a 3b over a 2. And then instead of dividing by g, because I don't want to do a fraction divided by g, I'm going to multiply by 1 over g. The reciprocal of g is 1 over g. And I wind up with x is equal to a 3b over a 2g, so I still wind up with the same answer. However, I'm not going to keep this one in the notes. It's up to you how you want to do that problem. I'll keep these 2 answers in the notes, or these 2 ways in the notes, so that way you know what to do in these 2 situations. Okay, so number 6, I'm solving for x. So x is being multiplied by a, and then I'm adding on a by. So first I'm going to take care of that addition of by subtracting a by from both sides. I wind up with an ax is equal to a c minus a by. And then a is being multiplied by x, so I'm going to divide by a on both sides. I just isolated x, and I'm left with a c minus a by over an a. This literal equation is no different than this type of equation. An ax plus a 7 is equal to a 9. So I would subtract the 7 first, and then I would divide by a. Same type of situation for number 6. All right, subtract by, and then divide by a. All right, number 7, I'm solving for x. So I have an m times an x, and then I have a plus b. I'm going to take care of that addition first by subtracting b from both sides. And I wind up with a y minus a b is equal to an m times an x. To get x by itself, I'm going to divide by m on both sides. And I wind up with a y minus a b over an m is equal to an x. You could also write your answer as a y over m minus b over m, but I'm okay with you leaving it like this. All right, next one. Remember, if your variable that you're trying to solve for is in the denominator of your fraction, we need to get that out of the fraction by multiplying by that variable on both sides. So I'm going to multiply by x on both sides. So I wind up with an xz is equal to an x divided by an x cancels, so I'm left with just a y. X is being multiplied by z. To undo multiplication, I'm going to divide by z on both sides, and I wind up with x is equal to a y over a z. Fractions aren't necessarily our friends in these situations, so we want to get rid of the fractions. That's why I multiplied by x. All right, number 9, the x is in the numerator. Technically, there's imaginary parentheses around that numerator. So I'm going to multiply by my denominator because I take care of parentheses last. Since I'm multiplying by multiple terms, I am going to need to multiply that 2 on the left side by both the y and the minus p. So I'm putting parentheses around the y minus p, so I know that I need to distribute this 2 in. So I have a 2y minus a 2p is equal to, and then a y minus p divided by a y minus p cancels, and I'm left with an x plus a 2p. So then that x, or attached to that x, is a plus 2p, so I want to subtract 2p from both sides, and I wind up with a 2y, and a minus 2p minus another 2p would be a minus 4p, and I'd be left with x. All right, that brings us to the end of this lesson.